All right, so yesterday we did something similar, but now we want to kind of specify again which angles are supplementary, adjacent, complementary, or all that stuff that you see 1 through 5 to specific angles. So if we look at this problem here, you have the graph to the right, and what we're going to have you now do is look for specific angles. So we want to be supplementary to angle AOD. So first, see if you remember what supplementary means, see if you remember how to find angle AOD, and then answer that question, see what we think. All right, let's see where we are at. So first we need to know supplementary. First and foremost, know it can only be 2 angles. So don't be starting to make supplementary angles out of 3 or 4 angles, because it's possible to do 3 or 4 to get a straight line 180. But it must be 2 angles only. And they need to add up to be 180 degrees, which is basically a straight line. So we're looking for what angle in addition to this angle. And then the third thing we need to know is how can we find this angle. So go from A, so here's A up here, to the O, which is right here, and then to the D. And then here is the D right there. So if I look at AOD, notice how that clearly is not a straight line. But what angle could be added to what I have right now shaded out in this darkness here? What angle could I add in order to create a straight line out of this? All right. Anybody think they got one of these? What is it? COB. All right, so from here you're saying to here. Do you see a straight line there, Ahmed? Because the angle you're adding right now is this guy. Right? So there's 2 ways we can extend one of those to get a straight line. So one of them would be right here. All right, don't I now have a straight line going up and down? So here's the angle that you were given, the black angle. So the next angle that I would want would be this angle right here. That would give us a straight line going straight up and down. So one of these we could say is angle CO and then D, COD. Follow that, Ahmed? There is another, however. So now let me extend this line, right? Because I could also create a straight line right here. Look at this partial angle. So the other angle that could make a straight line with the angle that you were given to work with is this angle right here. Because then that's going to create this straight line. So that angle, so we could also say angle BOA. All right, and that's an angle symbol here. All right, do we follow that? Does that make sense? Hopefully. Ahmed?
That makes more sense.
Okay. Yeah. Okay, number 2, adjacent and congruent to AOE. So let me, easy for me to do, maybe not as easy for you guys to just kind of erase this, but I want to find angle AOE first. So here is angle A to O to E. So I want to know what angle is right next to it. There are two angles right next to it. This angle is right next to it. And then the other angle that's right next to it is this angle right here. Well, yeah, this is actually pretty tricky. See what you think. I kind of want you to, let's see. This is sneaky. Some sneaky math here. Yeah. All right. So the nice thing about the angle that you were given to work with is we can look at this. That's our 90-degree angle. So if we look at the angle next to it, so let's look at this angle. This angle is adjacent to it. Any chance that's a 90-degree angle? Does that form a nice perfect T? No. So that's definitely not our answer. Here's where this gets a little sneaky, though. Let's go to this angle right here, because isn't this angle also adjacent to it? That obviously is not a 90-degree angle because I'm specifically telling you that that's a 60-degree angle, okay? So that's why that's a little bit sneaky, because there's a different way that we can say we have an adjacent angle to AOE. And that is by writing this angle here from C to O out to E. So isn't this bigger angle also considered right next to this 90-degree angle right here? Then notice how we end up with a straight line up and down. So then we know it's a 180. So this is 90 and this is 90. So the adjacent angle to this is the bigger angle. We don't want to use a 60-degree angle. We want to do the angle going from E to O to C. So angle E, O, C. Okay. That's not easy. That's hard to kind of visualize and understand. There's a different way to express an adjacent angle. All right. Next one. EOA. So here is E. Here is O. Here is A. Tell me what you think. This better be easy. All right. Now, why is this easy? Hopefully. Oh, my people just moved. Anybody think they got this? All right. There's only two ways to make this a supplementary angle. So look at the black angle that I have drawn in here. I could extend this line here. That's going to make a 180 degrees. Remember what supplementary means. It better be 180, which means it better form a straight line. So if I took this horizontal line and I extended it, that's a straight line. But here I'm just making it up. That doesn't exist on our graph. So we certainly can't be extending that line to create a 180 degree angle. But if I take this one and I extend it, notice this is how I can create a straight line. So what angle, in addition to this 90 degree angle, right? So here's 90 degrees. The other angle that's going to be 90 degrees is this big angle over here. And the reason I said it was easy, isn't it the same exact angle that we just talked about? So it has to be angle EOC once again. That's the angle that's supplementary. Okay. All right, 4, complementary. Remember what complementary is. First time we talked about it today. Complementary, again, 2 angles, so we can only have 2. And they add up to be 90 degrees. So find angle EOD. So E to O to D. What angle would we need to combine with that angle in order to create a nice 90 degree angle? All right. Cam, think you got this one? Angle D, O, D. From here to here to here. If we now make one big angle, this forms a nice, perfect T, nice 90-degree angle. Okay. Ahmed said, nice job, Cam. All right. Also keep in mind, we could have said DOC. The order of these, remember, doesn't matter. So if you wrote down that, don't think that what you wrote is wrong. As long as the O is in the middle, you're good. All right. Give me a pair of vertical angles. So we touched on this yesterday. As a hint, well, there's one obvious one, and then one tricky one. All right. I think we got that. What do you think, Cam? AOC. So you're going to go from here to here to here. All right. That's a straight angle. So as a hint, a straight angle, we could never have a vertical angle because you can't have an angle across from like a straight angle. Now, I like that line, so maybe here's what you're thinking of. That is one of the lines we want to use. The other line that we want to use is this line here. Then look at the angles that those create. It creates 4 angles. Those 2 lines create 4 angles. Darn it. So let me shade in these 4 angles. Here's one of the angles over here. And then if I go to the next angle above it, let me change it. Here's, come on. So now, think about what is directly across from the yellow, what is directly across from the blue. Troy just popped up here. I only see the messages very briefly. So let me pull up my chat here, see what Troy's got. All right, he says AOE and AOB. Not quite, Troy. Not quite. We're going to talk about one of those, but that's the harder one. Let's look at these guys right now. So let's look at this yellow one. What angle is directly across from this yellow angle right now? Then ask yourself, is that angle created by the red and the blue line exclusively? So hopefully, if we look right here, this is the angle directly across from it. Is that angle also created by only the red line and the black line? Yes. So that's one set of vertical angles. The BOA and angle COD. As you get better at this, I shouldn't say that's an easy one now as we're learning all of this. As you get better, that's the more obvious one. That's what I should have used. It's the more obvious one. But now look at your blue one. So let's look at our blue angle. Look at what is directly across from this, created by those 2 lines only. So it's not just this angle, right? Because is this angle created by the red line and the black line? No, it's created by the red line, but it doesn't touch the black line at all. So it's not that angle. If I go to the other angle right here, the blues are across from each other, but is this 60-degree angle created by both the black line and the red line? No, it's created by the black line, but it's not bordering the red line. But what if I combine those? So what if I do this? Now, isn't that big blue blob on the right-hand side bordered by those 2 lines, the red line and the black line? So that big angle now, so let's do BOC. So angle BOC, that's the original blue one that I have. So from here to here to here, So that's this blue stuff here. And then now it is directly across from and formed by the red and the black line, this big angle right here. So name that angle for me real quick. So write down how we're going to call that angle. All right, what is it, Cam? Good. A to O to D. And that's the one that's not quite as obvious because it's the combination of two angles that could be split up, but we want the big one. All right. Hopefully the shading there, as I look up it on the screen, is a little more obvious that way. All right, but those are our vertical angles. Okay. So seems simple, pretty tricky stuff. Now, this is easy. So this we're all going to think is easy. Oh boy, what just happened there? I just made a comment. Just finding the complement and the supplement. So remember, all we're doing for that is complement means we add up to be 90 degrees. Supplement means we add up to be 180 degrees. So for 20 degrees, you could probably do it in your head. It's a 70-degree angle. All you're really doing is you're going to do 90 minus 20. That should give you your 70. For 180, again, probably could do 20 in your head. 20 plus 160 equals 180. Now, when they're not nice, so like 45 and 89, then we can just fall back on the idea, take your original angle, subtract away the one that we know. Don't ask me why this is jumping around on me. Don't ask me that, Ahmed. That equals 45 degrees. Same with the supplement. All we really need to do is take the full 180, subtract the angle that I gave you, 45, and then whatever that gives us is our supplementary angle. Oh God, that is 135. Think about that for a minute. And then last one, 90 minus 89 means we have 1 degree. And then 180 minus 89 means we have 91 degrees. That is its supplement. So they need to add up to 80, add up to 90 or 180. The reason I write these little expressions is so that when I ask you to write this as a variable expression, think about what we're doing for each one of these. All we're doing every single time is taking the 90-degree angle, our supplement, and we are just subtracting away the angle that we know. That's how we can find out any complementary angle. Same with this. If I know supplementary add up to be 180, just subtract away the angle that you are given, and then that's our expression. All right. Okay, 6 and 7. Also, you will find these, I think, nice. Complementary angles. This thing's just doing this. Yeah, I don't know what's going on. Angle ABC is complementary to DBF. So ABC, complementary to DEF. What that really just means is those two angles added up equal 90 degrees. Well, here is ABC. That's 2x plus 2. Here is DEF. That's 3x minus a7. So when you were told that they are complementary, that means they should be added up, and we know that they must equal 90 degrees. Here's our equation that we need to be pretty efficient at. So combine your like terms. Add that 5 over. So 5x equals 95. Divide by 5, and we get x to be what? 19. Then answer your question. I want you to solve for x. So we have done that. X is a 19. And then I also want you to find the measure of each angle. So angle ABC is equal to this, 2 times x plus 2. So I'm going to do 2 times 19 plus 2. That's a 40-degree angle. Oops. And then angle DEF. Angle DEF is this expression, 3x minus a7. Although, do we need to plug that into the expression? Let's not make this too difficult. What do we know DEF now has to be if the first angle was 40? Right? It's got to be 50. Now, you could plug that in, so we can certainly plug it in right here, but it's a little bit more work. It's probably easier to just do the 90 minus the 40 and know that the other angle's got to be 50. All right? Okay, and then last one here. Same exact idea. You have two angles, angle 1 and angle 2, but I now use the word supplementary. So we need to know that just angle 1 plus angle 3 equals 180 degrees. That's pretty much what that first sentence is saying. As you read the second sentence, you are then told that angle 1 is 5x plus 1. We're going to add that to angle 3, which you're told is 7x plus 14. And when we do that, must equal 180. All right. Solve this equation. So add your like terms. So we have 12x's and a 15. And then that's got to equal. Subtract the 15. Uh-oh. Did I screw this up? Or did I just not give a good problem here? I don't think you're going to like this answer. Yeah, keep going. Decimals aren't impossible, so don't like freak out when you get a decimal. I'm freaking out right now because we do get a decimal, but decimals are okay. They're not illegal. I just want to make sure I didn't screw up. But no, it's all legit. All right, so then divide by 12. I'll need my calculator for this. What is it, 13.75? Okay. So then that x value should be 13.75. Go through, find your angles. So angle 1 is 5x plus 1. What do you got there, Ahmed?
I actually did the other one and I tried not get
But what'd you get for the other one then? I can do it. I'll get my calculator.
Using pretty sure.
Angle 1, 5 times 13.75 plus 1. Okay, thank you. Good. Then now it's probably easier here to just do the 180 minus the 69.75. That's what I would do. You could also just plug it in right here. Either way, doesn't matter. And then what was that? 110.25. Okay, and then those are our two angles. All right. All right. So with that, so you do have homework tonight, and it's just these next two pages. So whatever those pages are. / for Monday. Yeah, so 53 and 54. So you're going to do page 53 and 54 for homework. Okay, so you're going to do that for Monday night. If you have any questions, again, ask Monday during class so that we can help with that and make sure that you're all squared away. And then I couldn't have timed this any better, so dumb luck on my part. However, we made a little, we just kind of want to see where we're at again. This quiz, so you have a little exit quiz. So if you go to Canvas, you're going to see this right here. And just published it. So find that 5-4 exit quiz. This is for a little extra credit also. Okay, so if you're not sure how to do it, don't freak out. So here's today's date, February 19th. This is your guy. And we just want to see if you can do this little problem there. It's just one quick problem. We want to see where you're at. That's why it's extra credit. See what you come up with. Okay, when you are done, you're free to go. We will add this to the quiz category for those who didn't do particularly well on that quiz last week. This will get put into that category. All right. So good luck. Have a good weekend, and we'll see you guys on Monday. All right. Yeah, go ahead and finish it, but when you're done, you can go ahead and take off. Okay? Yep. Yeah, thank you. Yeah, no silence.